We're here in Northern Ontario. The temperature right now is minus 15 degrees, and behind me is a 100-year-old farmhouse, which, until it was renovated about a year ago, was costing about $900 a month to heat. This particular owner has gone to solar technology in order to reduce these costs by as much as 70%. We're going to take you through now and show you the various solar technologies that have been put in place to make this farmhouse a most enjoyable place to live. So come with us now and we'll show you around. Tell us about the types of solar panels we have here.
Okay, well, we've got two types of solar thermal panels here. The first bottom four that you see are flat plate solar liquid collectors, and the top two banks are vacuum tube solar liquid collectors. And inside these collectors we have a solution called glycol or antifreeze that's circulating. These collectors provide about between 40 and 50,000 BTU of heating peak per hour on themselves. So in other words, this can match the heating load requirements of the house up top. We have, today's about a minus 10 day Celsius, and on the panels themselves right now, if you look at this thermostat, we have about 92 degrees Fahrenheit or 30 degrees Celsius. So the good news is that inside in the house we have a tank that's storing the energy, about a 620 gallon tank, and it's right now about 101 degrees Fahrenheit, which is left over from the sunny weekend that we've just had. So when these panels reach more than 101 degrees, that will start the pump and start moving the energy into the house. But the pump will not turn on until the temperature exceeds what's in the storage tank.
This is a different type of solar panel. Can you tell us about this one?
Okay, this is a 1.5 kilowatt 2-axis photovoltaic tracking system. So this basically captures the sun's energy and turns it into electrical energy. It is connected to the electrical grid. So when people hear about grid-tied solar, this goes out to an inverter which is connected to my hydro panel, and that's then again connected to a meter, which basically slows the meter down, in other words, or produces electrical energy, which in turn comes back to me in form of a rebate if I'm not pulling as much power from the grid. All right, what we have here is a integrated thermal solar air wall, better known as solar wall. It's a process whereby aluminum or steel panels are perforated to allow air to come into them, which is then heated by the sun. This solar air wall can provide the heating and ventilation for this residence. Air is trapped inside the system. The air rises up via convection or hot air rising, and then it's fed down through a series of ducts or channels down into the furnace inside the residence. Used in conjunction with our solar liquid system, which can do the domestic hot water and radiant floor, these two systems can work very nicely together to provide heating and ventilation for the entire home. Another thing I'd like to point out about this system is aesthetically it's integrated very well into the siding. As you can see, the panel color matches the blue-gray siding on the house, so from an architectural or aesthetical integration, it's very well suited to this residence. What we have up top here is something called a solar window that we've created. There's a number of companies that are starting to design see-through or translucent photovoltaic windows. In this case, part of the window is shaded and the other part of the window you can look out of. This window can provide emergency power, battery backup for things like well pumps, or emergency lighting for residences in this case.
Well, Todd, it's nice to get in from the cold.
Yeah, it is.
It feels fantastic in here. It's very nice and warm. I know you told me you've got radiant floor heating, but tell me about it.
Well, basically what happens is that we have a hardwood floor here, and underneath the hardwood we have radiant floor coils, and those coils are heated by the solar array that we saw a little earlier. And downstairs there's a large tank where the hot water is stored, and that hot water is circulated through these coils in the floor.
And it's all heated by the panels that we've seen.
Yes, it is.
Great. So look, I'll tell you, I'd like to go and see the big tank and what you've got downstairs that makes this such a wonderful environment.
Okay, super.
Okay, let's do that.
Let's go.
Okay. We're here in the basement of the farmhouse. Now, behind me is a very large tank. Tell me what the function of that is.
Well, this is a 620-gallon solar storage tank. So this is referred to as long-term or seasonal storage in the solar world. And the solar liquid array that we saw earlier provides the heating source for this tank. So we can store anywhere from 1 to 3 or 4 days of solar energy in this tank, which can be used to heat the house and the floors.
Great. Now, tell me about this gray box on the wall. What is that? What's the function of that?
Beside me on the left is a wall-hung on-demand boiler, and this provides supplementary and backup heating for the house as well.
This looks like an ordinary furnace, but you tell me it's not. So what is the difference exactly?
Well, I'll tell you what's different about this furnace. This furnace doesn't have a burner. In this case, the burner is something called a hydronics coil, which is powered by solar hot water and our on-demand tankless boiler. As well, it has some ventilation equipment built into it called an HRV, which provides fresh air for the house. That furnace is also connected to our solar air panels, which you saw earlier outside, that are integrated with the building, as well as the solar hot water tank behind me here.
So this small grey blue box on the wall, you tell me is an inverter. Exactly what does an inverter do?
Well, this inverter takes the electrical energy we saw from the solar panels earlier and puts it back on the hydroelectric grid. Essentially, you're getting paid for the hydro that you're using, and any excess hydro goes back on the grid, and you get it back in terms of the form of a rebate.
Great. So, Todd, we've got a schematic here of everything we've seen today. Could you take us through it very quickly? And
sure.
Thank you.
Essentially, like they say, a picture's worth 1,000 words. So this is an illustration of a house that's pretty much representative of this home here. We were just in the basement a few minutes ago, and we saw our solar furnace. We saw our on-demand boiler, which is this picture here. We saw our large solar storage tank. And then outside earlier, we saw our integrated solar air wall, which is delineated by this particular picture. And then instead of being on the roof of this house, we had it off-site down below the hill. We had our solar liquid thermal array, and all of these systems, like you've seen, provide whole house radiant floor and forced air heating on the second floor as well. That's basically it.
That's great. Very simple. Todd, that was a great description of how this solar system works in this home. Very, very good explanation. Now tell me, the average consumer, what do they have to know?
Well, all the user has to do is learn how to work a thermostat, which they pretty much already know how to do. So in this case, if you want the room set, you just have to adjust the temperature accordingly. Right now, the room's set to 70 degrees, which is considered heating by most, and that's it.
Well, that's great. So, your solar home. We've seen how this particular homeowner has saved over 70% in the cost of heating their home through the use of 3 different types of solar technology. This is not just an energy saving story, but it's a story about a better living house, a house that's got good radiant floor heating, good clean air, and with the price of energy going the way it is, this is a system that you have to look into. This is your solar home.